Okay, this lesson is all about solubility of common ionic compounds in water. So as you can see, we're gonna apply the solubility rules in order for us to solve the problem. So I wanna go ahead and locate where you can find this information, which is the back of your periodic table. This one right here, you have certain informations, there's soluble compound and insoluble compound. And also, if you forget what these ions means, you can go back here. It has all those names. That's easy refreshed. So we're gonna explain what solubility rules are. Especially, this is one of the property of an ionic. So an ionic compound. So I'm just gonna go ahead and draw the flask. This one right here, I'm just gonna say that it is water. So an ionic compound, when it dissolves in water, it breaks into ions. So for this one, I'm just gonna go ahead and give you ammonium nitrate for you to figure out what the chemical formula is. So ammonium. So when I go back to my periodic table, which is the polyatomic ions, at the back right here, I can see that's the name of ammonium. And also, I can locate where nitrate is at the very bottom. You're gonna have to use crisscross. So basically, these are two different ions. When they dissolve in water, they become ammonium ions and nitrate ions. So I'm just gonna say nitrate ions. So they have two different ions when they dissolve in water. That's what they have. First, we're gonna have to go to see what solubility of common ionic compound is. So basically, with these compounds, this is the name. I break it down to the two different ions. So first, I look at ion soluble compound. So this one, basically, this is soluble. And I go back to nitrates. Also, nitrate is soluble. So this compound is actually soluble. So when it dissolves in water, you will write it down as an aqueous, which means it's soluble. However, when I'm going to go ahead and when so this is water. So when I put AgI, which is called silver iodide, into water, so it breaks it into Ag plus the L minus 1. So these are two different ions. So you're gonna go ahead and look at these ions. So basically, we will look at an anion first to see whether or not they are soluble. So this one, it says that it is soluble. Look at exceptions. When you have this one and this one, the answer will become insoluble. More importantly, you're gonna have to look at the information over here. As you can see, I was looking at iodide, which is I minus, and I also have exceptions. So and my exception will be silver iodide, which has Ag plus right there. So the combination of these two, it changed from soluble to insoluble. So I'm just gonna say this is soluble, but then with this exception, it makes it insoluble. So if it is insoluble, I will write out as a solid. What it means is that it will precipitate right there. So that will be AgI. Oh, I'm sorry. It will be AgCl, silver chloride. and this is water. That's what it is. If it is so insoluble means it's precipitate. So precipitate means a solid form. Now let's go ahead and look back at what are the last equations. So to see whether or not they are whether or not will, so whether or not when you dissolve these two things there will be a precipitate or not. Let's look at the question. So I'm just gonna mix sodium hydroxide with potassium carbonate. So this is sodium hydroxide, potassium plus carbonate. So when I do crisscross, this is it. So however, when the ionic compound dissolves in water, it breaks it into cation and anion. Cation, anion. So, and also with this chemical reaction, the cation will bind with the second anion, and the cation of the second one will combine with the first one. So basically, positive will bind with negative. Negative will bind with positive. So at the end, I should have two different products. So the first one would be sodium plus carbonate right here. And potassium hydroxide. So these are two different products that comes out of the precipitation reactions. So I'm gonna have to predict whether or not these two compounds will be soluble or insoluble. Let's look at carbonate ion first. Let's look at carbonate ion, they're insoluble. To see if there is any exception. So sodium is in group 1, so that makes it soluble. It makes aqueous solutions. And also potassium hydroxide. So I'm gonna go ahead and look at hydroxide is insoluble and look whether I will have alkaline metal. So this one makes it soluble because of the exceptions. So now I have two different soluble compounds, so I can't really distinguish. So to answer the question, so if there is no precipitates, so I will write down no reactions for this one. So this is how you would do it. I'm just gonna go ahead and show you the other one that will have a chemical of precipitates. Let me go ahead and erase some of the information that you may need, that we don't need. Let's try to see which one will not. Let's try silver sulfate. silver sulfate ions reacts with calcium chloride. Remember, have an exchange. So let's look at two different products that I do have. So that would be AgCl plus. The charges are the same, so basically I can just cancel them out. So that would be calcium sulfate. Now we're gonna go ahead and look at chloride ion to see whether or not that will have any exceptions. So basically, any iodide, bromide, chloride ion reacts the same way. Look at the chloride ion with exceptions, so that makes it soluble, or that makes it insoluble. Let me rewrite it. It makes it insoluble. How about calcium sulfate? Sulfate ion in general are soluble. So this one makes it soluble. So you're gonna have to write down that this has reactions. And we're gonna have to balance the chemical equations. So this will be an example of how we have to balance the chemical equations. I'm just gonna go ahead and you're gonna have to balance the chemical equation yourself using the prior knowledge that you have.